In this video, I'm going to go through an interesting question I found from the review questions at the end of your chapter. It deals with a compound shape, so I thought it would be good to see how we can use different formulas in here. So this is a solid sculpture with a hemisphere. So remember, a hemisphere is half of the sphere. And the radius is 3, and there's a right circular cone, so it's not a slanted cone, it just goes straight up with a slanted height L as shown in the diagram, so we don't know the value of L. Part A says show that the volume of the hemisphere is 18 pi centimeter cube. With questions that have show that, it's good to kind of remember what the form has to be. So if they wrote 18 pi, it means they didn't really want to evaluate the whole thing. So if you try out this question, you might face an issue if you just use the calculator. With show that they do expect you to do a bit of algebra work, so not really using a calculator, only if necessary. But because the question is not a decimal number, if they actually gave you a decimal number, then yeah, you'll have to use a calculator. In this case, you'll just need to use the formula for a sphere and then divide it into half just to get the hemisphere. Obviously, it doesn't look like a hemisphere, but remember that diagrams are never to scale. So you don't need to know the formula for the volume of a sphere. It's given to you in your data booklet. So the volume of a sphere is actually 4/3 times 3 cubed times, sorry, not 3 cubed, times, I skipped ahead there, it's times r times pi. So this is the volume of a sphere. For the hemisphere, we want to take this and then divide it by a half. So the hemisphere will be half of this. So I could do half, or you could do the whole thing and then write divided by 2, up to you. 4/3 times, sorry, the radius is cubed. So 4/3 times r cubed times pi. We know the radius, that's 3, so times 3 cubed times pi. Well, if I actually go through this calculation, just simplify it a bit. One of the 3 will cancel out with one of the 3 here, so it's going to end up being a half, and then 4 times 3 squared, which is 9, times pi. And then this 2 will simplify with the 4. So 2 goes 1, 4 goes twice. You just simplify them, or 4 divided by 2, up to you, however you want to do it. So you're left with 2 times 9, which is 18 pi. Just going to do it in a different way just to show you the different methods you could do this. So if you did 4/3 times 3 cubed times pi, and then the whole thing divided by 2. You can try 3 cubed if you didn't notice this cancellation, and you'll get times 27. I would recommend going through this step. It is good to always notice that you can cancel these out. So we are still back into this case. So you have a 4 times 3 squared times pi, and then this whole thing divided by 2, which is 4 times 9, so that's times pi divided by 2. Again, you can multiply this and you will get 36 pi divided by 2, which simplifies to 18 pi. So you can do it in many different ways. I'm going to stick to the first method just to not overload the page. So we found this. As soon as you get this to this step, then you're fine. Now, the volume of the hemisphere is 2/3 that of the cone. So that's very important information that we have here. Again, the volume of the hemisphere, which is this, 18 pi, is equal to 2/3. So 2/3 translates to this. that of the cone. So it's 2/3 of the volume of the cone. Just try to understand that sentence. So we need to find the vertical height. So the fact that they gave us this information should be a hint as to what you'll have to do. So we know the volume of hemisphere is equal to 2/3 of, remember that of in math translates to a multiplication. So it's 2/3 of the volume of the cone. And we know the volume of the hemisphere is 18 pi, so it has to be equal to 2/3 of the volume of the cone. Again, you don't need to remember the formula for the volume of the cone, but it's a third. It's given in the data booklet. It's a third times a pi times the radius squared times the height, which is what we need. So we are missing the height. So I'll just simplify this as we go. It seems like a big cluster, but we can simplify this. A third times a pi times, well, the radius is 3, so that's 3 squared times h. I'm going to simplify this very slowly. If you feel comfortable with this, you can skip ahead. So 18 pi is equal to, well, we can multiply these values out. Because it's a multiplication all throughout, I can just put one denominator, everything in a numerator, everything in a denominator. 2 times 1, that's 2, times pi times 3 squared times h, all divided by, we have 3 times 3, all of these are over 1. So 3 times 3 times 1 times 1 times 1, so that's just 3 times 3. Again, simplify it further. Let's not use the pi just yet. We don't really like to simplify with pi just yet because you'll notice it's going to cancel out. 2 times 3 squared is just 2 times 9, which is 18 pi h divided by 9. And then you end up with simplifying these values, so you get 2 pi h. We could have canceled the 3's out here. So you notice this is 3 squared, that's 3 squared, they cancel out. And then we divide by 2 on both sides, so you end up with 18 pi divided by 2. And so you have 9 pi on one side and then pi h on the other, and then we divide by pi on both sides. So these cancel out and you end up with 9 equals to h, or the fact that the height is equal to 9 centimeters. So quite a long process. I'm going to just delete this whole, or move it slightly to the bottom. So just a long process. You can really skip through the simplification. I went really easy on this just to show you and not skip ahead. You could do this in 3 lines very simply. So hopefully this was clear as to how to use that sentence in order to get this information. So the vertical height now is 9. Now we need to find the slant height of the cone. The slanted height of the cone will be basically just using Pythagoras now, because we have a right angle triangle here. Because this is a vertical height and L will be the hypotenuse. You could always consider right angle triangles in a cone. And so I'm going to do part C here. Part C, the L slanted height is basically 9 squared plus 3 squared, which is the square root of 90. You can leave it as the square root of 90. or you can round it, evaluate it to 9.49 centimeters. So that's the slanted height. Part D wants the angle between the slanting side of the cone. So we're looking at L now, and the flat face of the hemisphere. So this is the flat face of the hemisphere. So we're looking at this angle here. So we can use the 9 as the height. We can use this, which we can look at this right angle triangle again. And it's much better to use the 9 because it's a whole number rather than the 9.49. And in this case, we'll just have to use the trigonometric ratio. So we have the opposite, we have the adjacent, and we want this angle, and so we will have to use tan. So tan of our missing angle is equal to the opposite over the adjacent, and so our missing angle is equal to the tan inverse of 9/3, which is just equal to 71.6 degree to 3 significant figures. Hopefully this question was useful. Try a few more of these interesting questions from the back of your book and make use of these relations that they bring into the questions.